Hello everyone and welcome to the first public release of Flared2. Many of you are already downloading it and I hope you encounter no issues and that everything runs smoothly. However, some initial problem might arise, which is normal with new releases. Please feel free to reach out. We'll work on resolving any difficulties as they come up. Now I'd like to show you how I worked on this scene to create the lens flare. You're seeing the same effect featured in the background on our website, www.blenderlensflare.com. We'll start from scratch and go through useful techniques to improve viewport performance, especially when handling multiple flares and complex obstacles like the geometry of a car. Optimizing the viewport is essential for smooth workflow. Let's begin. Here is the clean scene. First of all, I'd like to thank BlenderKit. I'm not affiliated with or sponsored by them, but I downloaded this model using their free subscription and I'm using it under their terms. And this is a very good model, so thank you. For Flared, I'm currently working with version 0.62.0421, which we're gradually updating. There's a minor issue sometimes with the selection window. Sometimes icons appear and other times they don't. In theory, everything you click or scroll through with arrows key should display an icon, but as you can see, it's currently not showing. We're working on a fix for this. Some user asked if it would be more convenient to use the selection window seen in my earlier test videos. We opted for this new version because the old window didn't scroll well with too many elements. Now it's easier to navigate, search by name and sort lens flares alphabetically with visible preview in a consistent size. We'll continue to improve this preview, but for now this is what we have. Moving on to the program itself, in this scene I first placed some empties at point where I wanted to create flares, using them as anchors. This model is already optimized for headlight and illumination, but I also positioned the empty to work with the mirror function of this model, because if I applied a lens flare directly on the headlight, the mirror would place it in the center, but I wanted two distinct flares. In my opinion, the easiest solution is to use empties to position flares. For example, for the front headlight, I use these empties to create the emitted light. The default flare library offers a variety of quality flares, and I selected ones with long blue streaks and minimal starburst effect. Now, with the two empties selected, I click Add to apply the two flares. They don't appear right away because I'm not in camera view. I switch to camera view by pressing 0 on the keyboard, and as you can see, the effect is immediately visible and quite powerful. Now I link the two flares by selecting the two white dots. This way, when I modify one of the flares, the same adjustments apply to the other flare. However, it's essential to click on the panel icon to update for both linked flares so that the modifications replicate across both. Initially, I considered working in 3D mode, where flares shrink as the object moves away and grow as it comes closer. However, for this car animation, I don't believe is necessary. We can comfortably stay in 2D mode, where the flare size remains consistent regardless of the camera distance. Switching to 3D is possible, but here it seems irrelevant, so I leave everything in 2D. Next, I remove the sunbeams and starburst from both flares. When modifying one, I confirm in the panel to apply changes to both. I also remove the point light, a strong light source I don't need, and reduce the glow that diffused this blue light by adjusting its size while observing the effect changing. I notice hoop and halo are still visible, so I remove both to clean the effect. Now, there are still some ghost elements and a bit of dust which I prefer to remove for simplicity. Horizontal ghosts are barely visible in this preset. I also remove them to streamline the scene. After removing the dust, the result is cleaner. I then address the opposite glow, an interesting luminous effect expanding from the headlight, but I reduce it for subtler look. Moving on to horizontal streaks, they look fine, but might benefit from being slightly narrower to better match the headlight height. There are also green vertical streaks, which we'll address later by changing the color to blue. Finally, I review the other streaks, which are small horizontal light trails that extend from the main lens flare. Removing them has a minor but noticeable impact. In the initial scene, I had kept them dim for a less intrusive effect. Now we have achieved a balanced result without overly intrusive elements, I think. Another adjustment I would make is to change the color of the vertical streaks, which initially set to blue, and make thinner. I might also lower their height slightly. For this precise adjustment, I use the Shift key, which allows me for finer incremental changes and prevents overly sharp movements. Now let's examine why the streaks are currently green. This color comes from the default palette set by the artist who designed the lens flare. To change it, we need to raise the custom palette value to maximum and select the desired color. This process might seem a bit tedious, but it's effective for customizing colors. By setting the color to blue and updating the palette, we see that vertical streaks take on the desired shade. If there were other unwanted colors in the lens flare, we could adjust those as well, but it's unnecessary at the moment. Let's review the previous modification I made. I don't remember every specific details from the original settings, so I go through the main parameters to restore the project as closely as possible to the original. I just remember another important detail, the light reflection. This effect significantly brightens the scene, as the current preset sets the light reflection with a rather large scale. Now I'll try to reduce its scale. The light reflection is a simple image with transparency, an imported texture that moves opposite to the lens flare. I can lower the texture scale to make it less intrusive and apply this adjustment to the other flare as well. Now, both flares have a more subtle light reflection with reduced scale and brightness. The light reflection represents the reflection generated by the headlights, and there are various forms to choose from. After going through the options, I find a shape that seems ideal for the headlights, likely the same I used previously, yes. The final effect gives the impression of a realistic reflection from the headlights onto the camera sensor. Finally, let's review the main streaks, which still appear a bit intense. I reduce their brightness and slightly lower their height for a better balance in the scene. With these adjustments, this selection is now complete, and the overall effect looks more visually balanced and pleasing. Now let's move and check what have been done with the wheels. I'll re-enable the overlays to view the empties I positioned. I want to temporarily disable the two lens flares I'm not focused on, so I can concentrate solely on the empties. Once I've identified the correct empties, I select all four and add a lens flare to them. The program checks that there aren't already flares or other elements assigned to the empties, a slow but necessary operation. I then switch to the camera view to observe the result. We quickly notice an issue. The visible flares should be hidden by the car body, but aren't. This happens because we haven't specified that the flares need to be hidden when the car body is between the camera and the flare. So, to fix this, we select the collection containing the car components, labeled corpo and assign it to all the flare. Now the flares will automatically hide whenever the car body blocks the camera's line of sight. However, since the empties are positioned close to the wheels, we might encounter problems with this occlusion calculation, especially considering the heavy lag due to the car and its part being made up of numerous polygons generated by two subdivision surfaces. This complexity increases the processing time for occlusion, which relies on the CPU rather than GPU. With a lower-end CPU like mine, I have an Intel i5, this can significantly slow down viewport responsiveness. To reduce this problem, I activate geometry reduction with a level of 0.05, which helps reduce viewport lag by simplifying the car's geometry for occlusion calculations. Keep in mind that this adjustment doesn't affect the geometries in the render itself, only those used by Flared for occlusion. You can think of it as similar to a decimate effect. The higher the threshold, the more simplified the geometry becomes. Typically, a value of 0.05 yields a good result. Just note that increasing the value doesn't always linearly decrease lag, so feel free to experiment to find the settings that best suits your needs. Another way to reduce lag is by decreasing the numbers of flare performing occlusion calculations. Each flare performing this calculation adds to the lag, so reducing their numbers significantly improves the viewport fluidity. Another factor that can cause significant lag is the presence of active subdivision surfaces in the viewport, especially on objects involved in the occlusion. By reducing the subdivision level only in the viewport, without affecting the final render, we can achieve a much smoother viewing experience, making it ideal for working without excessive slowdowns. As you can see, the scene now runs quite well. There are still a few minor visibility issues, but the result is already acceptable for the current work. Let's now adjust the wheel flares to suit our preferences. We start by disabling the point light, which isn't necessary, and remove the unnecessary reflections that create excess light. Then we reduce the glow around the wheel to keep it more subtle while increasing the presence of the streak. These random details can also vary with the camera movement, and by adjusting the streak brightness, we fill the wheel area effectively. We also notice horizontal ghosts, which extends sideways. They're interesting in some scenarios, but here I don't need them, so I remove them from all flares. Finally, I observed that keeping the flares in 2D means the front wheel flares don't scale with the camera distance. To fix this, I switch them to 3D mode, reduce the scale slightly, and apply this adjustment to all flares, so they resize based on distance. I further refine the width of the streaks, making it less bright and slightly narrower for a balanced natural effect. I'll reactivate the front headlights, but I noticed that they too suffer from the same occlusion issue. To fix this, I assign the corpo collection to the headlight flares and set a geometry noise reduction value to of 0.05, as I did with the wheels, to apply the same occlusion calculations. Please remember always to link and to click on the update just to make all the modifications to the linked flares. As you can see, for a moment the flare is visible through the model because this model has open interior. Since it's hollow, the front light also appears from the back. To fix this, we could add an internal obstacle to block the flare from that direction as well. Let's move to the rear of the vehicle. I check the 3 empties for the rear lights, position on the left, on the right, and on the center. I select a red flare preset to match the rear lights and assigned it to the 3 empties. After linking the 3 flares, I switch to camera view to check the effect. I begin by removing the sunbeam and starburst, which don't suit for this type of flare. Then I reduce the glow scale, as it's too strong, to achieve a more balanced effect. I also decide to work in 3D mode here, so that the dimension will adjust with the camera distance. Now I notice something odd with the dust. It appears as an unappealing yellow-orange texture. I like the ghost extending towards the horizon, but I want to refine the dust. I adjust the dirt brightness and soften the dirt range for a more natural effects. I apply these adjustments to all the 3 flares. The dust still has a strange yellow tint, which comes from the point light color that also affect the dust. I change it to red, making it more realistic. Finally, as done previously, I set the flare to consider occlusion from the vehicle body. I set the geometry reduction to 0.05 and update the 3 flares for a cleaner, more realistic final result. Not much changes here, except for a slightly increase in interface lag, but now the flares should disappear correctly when occluded. On the homepage animation of the website, I had set a slightly larger glow and likely added horizontal ghost, which I don't see here. I could consider adding them, but as it stands, it's already seemed functional. However, I want to reduce the brightness of some ghosts, as they currently appears too intense. By adjusting the brightness, I achieve a more convincing and subtle effect. Now, I activate all the elements we've worked on to see the overall result. I'd say we've reached the desired outcome. In the background, the issue of hollow geometry remains, but to solve it, it would require manually filling of those areas because Flared can't do it. We've addressed the lag issues by reducing geometry, which also improves calculations of occlusion. Lowering the subdivision level for the car body simplifies interactions and makes the system more responsive. Let's move on the rendering. We set to HD with 64 samples for a detailed results. We launch the render and observe the output. I'd say the final result is pleasing and satisfying. That's all for today. I'll keep experimenting with other scenes and keep you updated with new videos. Thanks everyone and happy work. Ciao!